So good morning everyone. The three topics that I choose to explain is transaction processing system, decision support system, and export system. So first, I will discuss the transaction processing system. A transaction processing system is a set of information which processes the data transaction in database system that monitors transaction programs. The system is useful when something is sold over the internet. It allows for a time delay between when an item is being sold to when it is actually sold. An example of this is that of a sporting event ticket. While the customer is filling out their information to purchase the said ticket, the transaction processing system is holding the ticket so that another customer cannot also buy it. It allows for a ticket not to be sold to two different customers. The two types of transaction processing system are the batch processing and the real-time processing. Batch processing processes several transactions at the same time with a time delay. In the real-time processing, it deals with one transaction at a time and does not have a time delay. Also, transaction processing system has four features, which are the rapid response, reliability, inflexibility, and controlled processing. Rapid response is the response time of a transaction processing system, or the TPS, is important because a business cannot afford to have their customers waiting for a long periods of time before making a transaction. Reliability. A good TPS must be very reliable because if it were to break down, businesses could lose a huge portion of revenue because customers would not be able to purchase their products. Inflexibility. The TPS, or the transaction processing system, must work the same way for every transaction as long as the TPS is being used. The formality and structure should never change. In controlled processing, which is the last feature of the transaction processing system, in controlled processing, the TPS must be able to allow authorized employees to be able to access it at any time. A TPS must be able to easily be accessed by authorized employees so that information in the TPS can be retrieved. The information that goes through a TPS must never be deleted so that there will not be any confusion of what orders have gone through it. It is a good idea to have a backup and hard drive so that older information can still be stored, but will not slow down the server which houses the TPS, or the transaction processing system. The second is the decision support system, or the DDS. A decision support system, or a DDS, is a computerized program used to support determinations, judgments, and courses of action in an organization or a business. A DDS sifts through and analyzes massive amounts of data, compiling comprehensive information that can be used to solve problems in decision making. Typical information used by a DDS includes target or projected revenue, sales figures or past ones from different time periods, and other inventory or operations-related data. A decision support system gathers and analyzes data, synthesizing it to produce comprehensive information reports. In this way, as an informational application, a DDS differs from an ordinary operations application whose function is just to collect data. The DDS can either be completely computerized or powered by humans. In some cases, it may combine both. The ideal systems analyze information and actually make decisions for the user. At the very least, they allow human users to make more informed decisions at a quicker pace. Using a decision support system, the DDS can be employed by operations management and other planning departments in an organization to compile information and data and to synthesize it into actionable intelligence. In fact, these systems are primarily used by mid to upper level management. For example, a DDS may be used to project a company's revenue over the upcoming 6 months based on new assumptions about product sales. Due to a large number of factors that surround projected revenue figures, this is not a straightforward calculation that can be done manually. However, a DDS can integrate all the multiple variables and generate an outcome and alternate outcomes, all based on the company's past product sales data and current variables. So that would be all for the decision support system. Next, I will discuss the expert system. The expert systems are the computer applications developed to solve complex problems in a particular domain at the level of extraordinary human intelligence and expertise. So an expert system are one of the prominent research domains of AI. Expert system has its own characteristics. It has high performance, it is understandable, it is reliable, and it is highly responsive. The expert system are capable of advising, instructing, and assisting human in decision making, demonstrating, deriving a solution, diagnosing, explaining, interpreting input, predicting results, justifying the conclusion, and suggesting alternative options to a problem. And they are incapable of substituting human decision makers, possessing human capabilities, producing accurate output for inadequate knowledge base, refining their own knowledge. An expert system components includes knowledge base, inference engine, and the user interface. We will discuss the components of an expert system. First, I will discuss the knowledge base. Knowledge base contains domain-specific and highly quality knowledge. Knowledge is required to exhibit intelligence. The success of any ES or expert system majorly depends upon the collection of highly accurate and precise knowledge. So knowledge is the data collection of facts. The information is organized as data and facts about the task domain. Data, information, and past experience combined together are termed as knowledge. And knowledge base has also its components. So next we will discuss the components of knowledge base. The knowledge base of an expert system is a store of both factual and heuristic knowledge. Factual knowledge means It is the information widely accepted by the knowledge engineers and scholars in the task domain. Heuristic knowledge, it is about practice, accurate judgment, one's ability of evaluation and guessing. Knowledge representation, it is the method used to organize and formalize the knowledge in the knowledge base. It is the form of if, then, else rules. Knowledge acquisition. The success of any expert system majorly depends on the quality, completeness, and accuracy of the information stored in the knowledge base. The knowledge base is formed by readings from various experts, scholars, and the knowledge engineers. The second component of an expert system or ES is the inference engine. Use of efficient procedures and rules by the inference engine is essential in deducting a correct, flawless solution. In case of knowledge-based ES, the inference engine acquires and manipulates the knowledge from the knowledge base to arrive at a particular solution. In case of rule-based ES, it applies rules repeatedly to the facts which are obtained from earlier rule application. It also adds new knowledge into the knowledge base if required. And it also resolves rules conflict when multiple rules are applicable to a particular case. To recommend a solution, the inference engine uses the following strategies, which are the forward chaining and the backward chaining. Forward chaining is a strategy of an expert system to answer the question, what can happen next? Here, the inference engine follows the chain of conditions and derivations and finally deduces the outcome. It considers all the facts and rules and sorts them before concluding a solution. This strategy is followed for working on solution, result, or effect. For example, prediction of share market status as an effect of changes in interest rates. The next strategy of an inference engine is the backward chaining. With this strategy, an expert system finds out the answer to the question, why this happened. On the basis of what has already happened, the inference engine tries to find out which conditions could have happened in the past for this result. This strategy is followed for finding out cause or reason. For example, diagnosis of blood cancer in humans. The last component of an expert system is the user interface. User interface provides interaction between user of the ES and the ES itself. It is generally natural language processing so that as to be used by the user who is well versed in the task domain. The user of the ES need not be necessarily an expert in artificial intelligence. It explains how the ES has arrived at a particular recommendation. The following explanation may appear in the following forms. First, in the natural language displayed on screen. Second, in the verbal narrations in natural language. And then lastly, in listing of rule numbers displayed on the screen. The user interface makes it easy to trace the incredibility of the deductions. We will discuss the requirements of efficient ES user interface. The requirements of efficient expert system user interface are it should help users to accomplish their goals in shortest possible way. Next, it should be designed to work for users' exciting or desired work practices. Third is technology used to be adaptable to users' requirements, not the other way around. Lastly, last requirement, it should make efficient use of user input is the expert system's limitations. No technology can offer easy and complete solution. Large systems are costly, require significant development time, and computer resources. Expert systems have their limitations, which include limitations of the technology, difficult knowledge acquisitions, ES are difficult to maintain, and highly development costs. Systems are beneficial in terms of availability, less production cost, speed, less error rate, reducing risk, and steady response. In availability, they are easily available due to mass production of software. It is also beneficial in less production cost. Production cost is reasonable. This makes them affordable. In speed, they offer great speed. They reduce the amount of work and individual puts in. In less error rate is low as compared to human errors. In terms of reducing risk, they can work in the environment dangerous to humans. Expert systems is beneficial in terms of steady response because they work steadily without getting emotional, tensed, and fatigued. So that would be all for my discussions